Hey folks, in this video we're going to go over the actual implementation of the Point2D ADT. Okay, so I have this huge class up here on the screen. Let's try walking through it. So I have, of course, my class being defined, Point2D, and I have two things inside of it. So I have basically X and Y. Private final double, private final double. Private, best practice, right? We want this thing to be encapsulated. We don't want people to tinker with the variables from outside. That seems good. Final is actually going to make this class, or it's a part of making this class immutable. Remember that earlier we had some issues with references, and we said that, oh, one way to address this is basically to make a class immutable so that nobody can change the contents of it. Well, that's actually happening right here. Our Point2D class is immutable, and so it won't be subject to any of those referential issues. So back to my code. So I have X and Y, that looks good. The one thing you may wonder about here, and there's a little prompt there in the slide for you, is it okay to do final without an assignment? So as a reminder, the final keyword is basically marking something as a constant in Java, basically saying this is one value that it cannot change. And last time we saw final, we did an assignment. We actually assigned it to a certain number. But here, right, we're not doing that. So is that okay? Well, here it is actually fine in Java. What happens is that when we use the keyword final there in a member variable, what we're doing basically is we're saying, you know, I only want that ever to have one value, but I'll let you assign it just once inside the constructor. So in the constructor, I can assign X and Y. Right? Anywhere else in my program I cannot assign it, it's locked in place. So it's kind of like Java understands, right, that you want to assign something but you need it to come in as an input parameter. And so it'll give you that little moment in time, right, to save it there in the constructor, and then it becomes permanent from then going forward. So that is the fine thing to do. All right, our next couple of methods, right, so we have here our constructor. Our constructor is, setting up X and Y, pretty straightforward. Then we have X and Y themselves, right, which are basically providing access to those pieces of data. Note that this is sort of an interesting stylistic choice here. So our book uses X and Y, and this is a little bit different from what you may have seen before, which is things like get X or get Y. Different people have different thoughts on this. For you guys, probably you should stick with get X and get Y because it's a very standard thing. Now, the reason why they've omitted that here is because it's implied that, well, if this is immutable and I can't change things, you're not going to have anything that looks like a setter. It's all going to be getters. So it's redundant to have the extra word there. So they just have X and Y. But because all of you guys are typically using classes that have get and set, it would be nice to be consistent with that. Number one thing, right, when you talk about style, when you talk about, how you write code, is consistency. Because the more consistent something is, the easier it is for people to understand. All right, back to our code. We have R and theta. And I completely skipped over it, but you'll notice, right, our internal representation is indeed X and Y, right? Which makes sense for the previous example because the previous example used X and Y a couple of times. So it seems reasonable to store it as X and Y. And that made, right, these things here, right, very simple, right? Those are very straightforward. So now we have R and theta. Now R and theta, right, both take math, right? So R basically, right, we have the square root of squares, right, of X and Y. Then for the theta, right, I do an inverse tangent, right, on X and Y. So it's a little bit more work. Obviously, right, if I have an internal representation X and Y and I'm calling my R and theta a lot, I'm going to be running those things a lot. I'm going to be doing a whole lot of square roots. I'm going to do a whole lot of inverse tangents. That is going to be an expensive set of operations, right? And I do want to avoid that. So in that case, right, if I was using R and theta a lot, I should just store those natively as doubles and then make the math happen for X and Y. So yeah, that there you can see some performance considerations. Next thing is distance 2. Distance 2 is relatively straightforward. We're just kind of using the standard formula, so we're taking the difference in X and Y, square root of that squared, okay? Then we get back to our distance, and we're good to go. So let's see. Okay, so on the right-hand side, we have basically our common methods, ones that we have to override. Remember that there are those methods, right, equals hash code, toString, right, that Java basically gives all the classes for free. And there's kind of this basic implementation that comes from this overall object parent. But for us, right, we know a little bit more, right? We're a little bit more specific. We're not just a generic object. We're actually an object that represents this Point2D concept. Well, because we're a little bit more specific, we should update our methods, right, to kind of line up. So the bottom one, right, is the most simple one. It's toString, right? We have an override there. And the way we update it is to print out kind of this friendly notation. So we're printing out X and Y. If we don't do this, we'll get this little random number instead, right? It'll say the class name and then some random address looking thing. Here, right, we're overloading it, we're making it a lot more, or overriding it, we're making it a lot more specific to our particular class. Up top, we have equals, and equals here, equals is actually a lot of code. It's the most complicated thing here. And we'll actually walk through this a little bit. So equals. So what's going on here? Basically, right, I'm implementing this so that if I have 2 points, I can compare them and check to see if they're the same thing. That's what we had in the example for the client of the Point2D. We created 2 different points with 2 different uses of the keyword new, and then we asked the question, are these 2 things the same or not? And the way we did that was by kind of the equals command, or equals method. So how does it work? So first of all, right, you may notice that in the parameters are a little bit interesting because it takes in an object. It doesn't take in a Point2D, right? Over here for like distance too, that took in a Point2D because it only makes sense to compare distance between points. But for equals is very generic, right? It's coming from basically that top level object class. It doesn't even know about Point2D, so the typing on that is actually just object, right? So basically, you can be compared equals with anybody out there in the system, okay? So it could be anything we're getting in. So it takes a little bit of work to basically check to see whether it's even safe to compare ourselves with that other thing. All right, so the first thing is actually kind of an optimization. So we check to see whether the thing I'm being compared to is actually myself, right? Is my address equal to the address of the thing I'm comparing? If that is the case, return true. Done, right? So that is actually not strictly required for us to have here, but it is nice from an optimization standpoint because that's basically the fastest possible check you could ever perform. All right, next thing there, other equal null. Basically what we're saying is, am I being compared to anything, okay? So if I even exist, right? If I exist, right, which I must exist, right, in order for equals to be called on me, and I'm compared to somebody that doesn't exist, how could it ever be equal, right? Something that exists doesn't ever equal something something that doesn't exist or doesn't ever equal something that exists, okay? So that's kind of another early check to say, hey, is there any possibility there? If that ends up being the case, then we return false because there's nothing to compare, right? Cannot possibly be equal. All right, third thing. Now we kind of are more specific. We ask the question, is my class, Point2D, the same class of the object that's being passed in as a parameter? Because I want to compare a class and a class. I don't want to compare a class and a string. Class and string are definitely not going to be equal. Okay? So I check to see whether the classes of these objects are the same. If they aren't, then I return false because there's no way they can be equal. All right, so we've done a whole lot of checking up front, and we have finally verified that we are looking at another Point2D that is not ourselves. So what do? We compare instance variables. Is my x the same as their x? Is my y the same as their y? If these things are true, then yeah, we are equal. I can return true. So that's there. The previous line, which I kind of skipped over, basically that's just a cast. Because remember, the parameters come in with a type object, and so it's just an object, right? I don't know much about it, but I have kind of confirmed in the previous line that its class matches mine, so I know it'll actually be safe to cast it to a Point2D. And I have to class it to that Point2D before I can call x and y, right? Because x and y don't exist on just any old object in the system. They exist only on instances of this Point2D class. All right, so that's our equals method. So overall, right, this is an implementation for Point2D, right? Our observations here is that we basically have implemented the entirety of that API, which we used in the client, and we picked, right, the x and the y as a representation for our internal data type, right? Could have picked something else, but for now we picked, x and y, and everything seemed to come together just fine. So yeah, this is a complete implementation of Point2D, a very kind of concise one that is, right, again, an immutable type, right? So there's no way for me to change the data inside of it, so we don't have to worry about any of those referential issues.